Good morning, everyone. Today we're going to work on this question called move zeros. It's a very common question, and I think it's asked by Facebook. So let's get started. Given an array nums, write a function to move all zeros to the end of it while maintaining the relative order of the non-zero elements. Okay, so let's look at our example here. We see, okay, 0, 1, 0, 3, 12. We want to move these zeros to the end of the array and compact these non-zero elements to the left, right? And so note, you must do this in place without making a copy of the array and minimize the total number of operations. So if we were doing this not in place, we could just kind of filter this array by non-zero elements, put that in a new array, and then extend that new array by the original length, by the difference between that array and the original length of that array. But we're not doing that, so you must do this in place. So when you think in place, think swapping or reassigning variables, okay? So our solution we're going to do is we're going to keep track of two different pointers, okay? One pointer is going to iterate through the entire list, looking for non-zero elements. The other pointer is going to keep track of the leftmost index that we can swap, we can push a non-zero element to. So basically, both indexes start here, right? This is a zero element. This is non-zero. This is a zero element, so we go to the next. Our I counter is going to go here. Okay, this is a non-zero element, so swap it with our next available compacted spot, right? So here goes, this goes to 1, right? And then our next compacted spot becomes the first index. And this is here. And then we go, okay, 3. Put it where our next compacted spot, available spot is, okay? Now our next available spot is here. Okay, find 12. 12. Put that where our next available spot is. Put that in the second index. Okay, now our first counter has gone through the entire list. There's nothing past 12. Okay, so now we know that we've compacted to the left all the non-zero elements as much as we can. So all the elements from our non-zero, from our next available spot index onwards are going to be all zeros. And that's what we're going to do. Alrighty, so we have our 0 index. That's at 0. And we're going to say for every value in the array, right, let's iterate through that. So we'll say, okay, for I num in enumerate nums, right, if num does not equal 0, right, we want to move that num to our leftmost available index. So make that there, and we're going to increment our 0 index by 1, right? So, and just in the first iteration, actually, let me print out our 0 index, our I, our num, in our nums here, just so we can see what's going on. Oh yeah, that should be nums. Cool, so you see that our 0 index is moving up by 1 every single time, right? Basically, first it's here, right? Then it's here. We've already moved the 1 to the left of it, and so any future non-zero elements are not going to go before this index. They can go after it. So that's why when we find the 3, when our counter is equal to 3, we'll move the 3 to this next available spot. When we find the 12, we move it to our next available spot. And then, after this loop, we know we've basically gone through all the non-zero elements of the array. So everything beyond this index can be turned into zeros. And that's the next spot we're up to. So we'll say here, okay, while 0 index is less than the length of nums, just nums of 0 index equals 0. Right, assign everything to 0 and increment our 0 index, and then we'll return. So actually, I'm going to keep these in here just so we can see how it's behaving. And then one last time here. Right, so once you have your original array, this part looks confusing, but really, you know these values have been moved already. And so since they've been moved already, you can move everything, you can replace them all with zeros. So this becomes a 0, and this becomes a 0. And we're done. So let's submit. But first I have to unprint all these things. I think last time I did this, it gave me a problem about output limit exceeded. So sweet. Okay. And this is great because we're iterating through the list basically once with 2 counters. So well done. O of n time. O constant space. We're not creating a new list. And yeah. If you enjoyed the video, please like, comment, subscribe. Otherwise, I'll keep getting better. Thank you.